Hello, my name is Reza Kashtiban and I'm a scientist at the microscopy unit of University of Warwick. Microscopes are a fundamental part of any scientist's toolkit and allow us to investigate items which are too small to see with the naked eye. There are several different types of microscopes and scientists can choose which type of machine they require to use depending on the information they need. Two different types of microscopes are light microscopes and electron microscopes. A light microscope should be familiar to you and uses visible light and an arrangement of lenses to magnify objects up to few hundred times of their original size. For example, at 500 times magnification, an object which looks 50 millimeters in size would actually be only a tenth of a millimeter in reality, which is the thickness of one of these wires on this electronic board. Scientists use light microscope to look at biological samples like cells as well as different man-made materials. Within the supercritical electrodeposition project, we inspect material at the nanometer scale. Light microscopes are limited by the wavelengths of visible light. Our materials are far too small to see with light, so we need something with even smaller wavelength, electrons. We are in one of electron microscopes room at the University of Warwick. Electron microscopes use a beam of electrons instead of light and magnets instead of glass lenses in a similar fashion to the light microscopes. There are two main types of electron microscopes. Scanning electron microscopes or SEMs like this one behind me, and transmission electron microscopes or TEM. In SEM, magnifications of several thousand times are possible, and this technique is used to look at the surface of the samples. What you can see on the screen, it's not a piece of football. You can't put football in SEM electron microscope. This is a close-up view of something very different. Moving out of magnification and going to a smaller magnification, you can actually see what was the sample inside the microscope. This is an eye of an insect. We use SEM for features as big as tens of nanometers and not smaller than 10 nanometer. Normally, SEMs make black and white images, but these can be artificially colored later on. We are in a transmission electron microscope rooms at the University of Warwick, and I am in front of one of the most powerful transmission electron microscopes in entire world. This room is a purpose-built room, and to be able to see individual atoms, we need to stabilize the microscope. So the room is temperature controlled and the microscope is isolated from the rest of the building. Transmission electron microscopes passes electrons through a thin slice of the sample in the same way as the optical microscopes. Magnetic lenses focus the highly magnified image onto a phosphor screen or photographic film or charge coupled device CCD in a digital camera. TEMs are especially useful in studying the structures inside crystals and particles. What you see on the screen is a graphene sample, well, the most thinnest material and also strongest material. This sample is spotted with gold atoms, and you can see on the screen gold nanoparticles, and also you can see individual gold atoms as a dark little spots on the screen. For very small pores, especially for those samples which are filled, we need to use very advanced and sophisticated electron microscopes capable of resolving less than 1 nanometer. For doing this, we use our aberration corrected electron microscope capable of resolving individual atoms.